Episode 14, titled OWASP, Top 10 and MASVS, we're going to use OWASP language as a practical way to describe common application risks without getting lost in tool talk or vendor jargon. Pen Test Plus questions routinely expect you to recognize patterns in web and mobile issues, and the OWASP vocabulary gives you a clean, widely understood way to label what is happening and why it matters. When you can name a risk category correctly, you can also reason about likely causes, likely evidence, and safe next steps for validation. That matters because application findings often sound similar at the surface, but their root causes and the right response can be very different. MASVS adds a parallel set of expectations for mobile, helping you think about what secure should look like across storage, networking, and permissions. The goal in this episode is to make these frameworks feel like practical labels you can apply quickly when a scenario gives you behavioral clues. OWASP Top 10 is best understood as a set of recurring web risk categories and patterns, not as a checklist of specific exploits. The value is that these categories describe the kinds of mistakes that show up over and over across many technologies and organizations, even when the exact implementation differs. On the exam, you rarely need to recall an exact title perfectly. You need to recognize the pattern the scenario is pointing to and select an answer that aligns with that pattern. The categories are useful because they connect symptoms to causes and causes to appropriate validation steps without requiring you to memorize every possible variant. This is also why OWASP language shows up in professional reporting. It gives stakeholders a familiar taxonomy to understand what type of risk they are dealing with. When you see web scenarios about authorization, input handling, authentication flows, or misconfiguration, an OWASP category is often the cleanest way to frame what is happening.
Access control failures are one of the most common and most consequential application risks, and they matter because authorization mistakes can quietly turn normal features into unauthorized power.
The key idea is that authentication answers, "Who are you?" while authorization answers, "What are you allowed to do?" And many serious incidents happen when the second question is answered incorrectly. In plain terms, access control failures occur when a user can perform actions or access data that they should not be able to reach, often by manipulating identifiers, paths, roles, or requests. The impact can be severe because it can expose sensitive data, allow account changes, or enable fraud, and it often scales across many users if the control logic is flawed. Exam prompts may describe one user seeing another user's records, performing admin actions, or accessing restricted functions, and those are strong cues for access control risk. When you classify the issue correctly, you are more likely to choose an answer that emphasizes authorization validation rather than chasing unrelated technical details. Injection risks can be described in a single plain language idea: untrusted input becomes executed action. Instead of treating injection as a magic word, focus on the pattern that the system takes user-controlled data and treats it as instructions in some internal interpreter. That interpreter could be a query system, a command environment, or another processing layer. But the exam mostly cares that you recognize the cause and effect relationship. Injection matters because it can allow attackers to change how the system behaves by crafting input that breaks intended boundaries, leading to unauthorized access, data manipulation, or control over behavior. Scenario cues often include unusual behavior tied to crafted inputs, errors that reveal interpreter behavior, or results that suggest the system is executing something it should have treated as data. A disciplined mindset recognizes that the risk is not input exists, but input changes meaning, and that is why validation focuses on how inputs are handled and constrained. When you see this pattern,
The best answers tend to align with investigating input handling and execution pathways rather than treating it as a generic bug.
Insecure design is an important category because it emphasizes missing safeguards, not just coding mistakes or typos. The idea is that the system's design lacks controls that should exist to prevent misuse, even if the code is written cleanly and the infrastructure is stable. Insecure design shows up when a workflow allows dangerous outcomes because the necessary safety rails were never built into the business logic or architecture. Exam scenarios may describe features that allow sensitive actions without adequate checks, processes that assume trust where trust should be verified, or systems that fail safely under abnormal conditions. This category matters because it changes the remediation conversation, since the fix may require redesigning a workflow rather than patching a line of code. It also changes how you reason about best next step, because validating insecure design often involves mapping the logic and identifying where safeguards should exist. When you recognize insecure design, you look for answers that focus on control gaps in the design, rather than answers that treat the issue as a single isolated defect.
Authentication and session issues form another major web risk pattern, because weak flows can enable account takeover or unauthorized access even when the rest of the application is well built. The core concept is that the system's identity verification and session handling must remain robust under real-world conditions, including repeated attempts, session reuse, and user behavior. Weak flows might allow attackers to bypass authentication, hijack a session, or maintain access longer than intended. And the exam often describes this through symptoms like unexpected logins, sessions that persist improperly, or inconsistent enforcement of identity checks. The key point is that authentication establishes identity, while session management sustains identity, so failures in either can undermine access controls downstream. When you classify the scenario correctly, you can choose validation steps that focus on identity and session behavior rather than chasing unrelated vulnerabilities. In test questions, the best options often involve examining how sessions are created, maintained, and invalidated, because those are the mechanics that determine whether account takeover is feasible. Security misconfiguration is a category that often produces high-value findings because it represents unsafe defaults, exposed management surfaces, or overly permissive settings that create unnecessary exposure. The pattern is that the system is not hardened appropriately, and as a result, it reveals functionality or access that should not be available in normal operation. Exam cues include exposed administrative interfaces, default credentials, debugging features, overly permissive settings, or services that should not be reachable from the described context. Misconfiguration is especially tricky because it can look like an easy win, but the professional response still requires safe validation and respect for scope, timing, and operational stability. This category also ties closely to risk language because the same misconfiguration can have very different consequences depending on what it exposes and what controls exist around it. When you see misconfiguration cues, the best answers often favor confirming exposure safely and documenting clearly rather than leaping to aggressive proof that could disrupt production. Recognizing the category helps you justify why the issue exists and what kind of control failure it represents. MASVS is best thought of as a set of mobile security expectations that span storage, networking, and permissions, helping you evaluate whether a mobile app behaves safely in a device-centered world. Mobile contexts introduce different risk surfaces because apps interact with device storage, local logs, backups, and operating system permission models in ways that do not map cleanly to web-only thinking. MASV gives you a structured way to think about what should be protected, how data should be handled, and how app behavior should respect device posture and permission boundaries. On Pen Test Plus, you are not typically expected to recite MASVS sections, but you are expected to recognize the kinds of risks MASVS is designed to address. The value is that it keeps you from treating mobile as just web on a phone, because mobile introduces local artifacts and permission-driven behavior that can change both likelihood and impact. When you see mobile scenarios involving storage, logging, or permission misuse, MASV thinking helps you frame what expectation is being violated.
Mobile data risks are a prime example of why mobile frameworks matter, because local storage, logs, backups, and caching behavior can quietly turn sensitive data into an exposure.
The pattern is that data that should remain protected ends up stored in places where it can be accessed more easily than intended, especially if device posture is weak or if an attacker gains access to the device or its backups. Logs can inadvertently capture sensitive values, backups can preserve data longer than expected, and caching can leave artifacts that persist beyond a user session. The exam may describe symptoms like sensitive values appearing in logs, data persisting after logout, or unexpected exposure through local storage behavior, and those cues point toward mobile data handling weakness. A professional mindset treats these artifacts as part of the attack surface because the risk is not only network interception, but also local extraction. When you can reason about mobile data risk, you are better prepared to choose answers that emphasize minimum necessary handling and controlled validation. A frequent confusion in application questions is mixing vulnerability names with impacts, and that confusion leads to sloppy reasoning that the exam can punish. Vulnerability names describe causes, such as an access control failure or injection pathway, while impacts describe consequences, such as data exposure, account takeover, or operational disruption. Keeping cause and effect separate helps you avoid exaggerated claims, because you can state what category of weakness is present and then evaluate what impact is likely in the described context. It also helps you pick better answers, because the correct next step depends on the cause, not on the most dramatic possible impact. If a prompt describes unauthorized access to data, you should identify the likely access control weakness, then assess impact based on what data and what roles are involved. If a prompt describes input-driven execution, you should identify the injection pattern, then assess impact based on what the execution environment can reach. On Pen Test Plus, answers that keep cause and effect aligned tend to be more defensible and more correct. Now walk through a web scenario and name the likely OWASP category based on behavior cues rather than on buzzwords. Imagine a prompt where a standard user can change a numeric identifier in a request and suddenly view another user's records, even though no elevated role was granted. The defining behavior is unauthorized access to data by manipulating a request context, which points strongly to an access control failure. The important insight is that the system is authenticating the user, but it is not enforcing authorization correctly for the resource being requested. In such a scenario, the best next step choices often involve confirming the authorization boundary and documenting evidence of cross-user access rather than chasing unrelated weaknesses. If another option suggests focusing on input validation in a generic way without tying it to authorization enforcement, it may miss the scenario's core risk. Naming the category helps you select actions consistent with the likely root cause and with professional reporting language. Now consider a mobile scenario and connect it to the MASVS area it touches by focusing on what expectation is violated. Imagine a prompt where a mobile application stores sensitive user data locally, and even after logout, the data remains available in a cached form or appears in logs that can be accessed through device artifacts.
That scenario is primarily about mobile data storage and data exposure through local artifacts, including caching and logging behavior, which is exactly the kind of expectation MASV addresses under secure data handling. The key is that the risk is not only what happens over the network, but what remains on the device, because the device is part of the security boundary in mobile environments. A correct reasoning path would highlight that sensitive data should be protected at rest and should not be left in easily recoverable artifacts beyond what is necessary for functionality. In exam terms, this classification helps you choose answers that emphasize protecting stored data and limiting unnecessary persistence, rather than focusing exclusively on network transport assumptions. When you can map the scenario to the expectation, you can justify why it is risky, even if the app's network behavior appears normal. For a short recall drill, you should be able to name 5 common categories without hesitation, because speed matters when the prompt is dense. The goal is not to list everything perfectly, but to have a set of category labels that cover the most common patterns you will recognize in questions. Access control failures should come to mind when you see unauthorized actions or cross-user data access. Injection should come to mind when untrusted input appears to change system behavior as if it were instructions. Authentication and session issues should come to mind when identity or session behavior enables takeover or bypass. Security misconfiguration should come to mind when unsafe defaults or exposed management surfaces create unnecessary reachability. Insecure design should come to mind when the workflow lacks safeguards and allows dangerous outcomes even without a specific coding error. If you can recall those quickly, you can often narrow answer choices to the ones that align with the right root cause.
In this episode, the practical takeaway is that OWASP and MASVS give you disciplined language for describing common application risks in a way that supports accurate reasoning and credible reporting. OWASP Top 10 helps you recognize recurring web risk patterns such as access control failures, injection, insecure design, authentication and session issues, and security misconfiguration, and it keeps you focused on causes rather than hype. MASVS provides a mobile-centered expectation lens that highlights risks in storage, networking behavior, and permission-driven posture, especially where local artifacts like logs, backups, and caching can expose sensitive data.
Keeping vulnerability names separate from impacts helps you remain precise, because causes drive next steps while impacts depend on context.
Now, classify one app risk you know well by naming its likely OWASP category or MASVS area, then state the likely impact in plain language without exaggeration, because that practice is how the labels become usable under exam pressure. When you can apply these frameworks as lenses, Pen Test Plus questions become less about memorization and more about pattern recognition with professional clarity. Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.